Now this next section deals with correlation, and here we have, and correlation is even though you may not have some units in one area, if you have other units that you can match in a distant area, then we can link those being formed at the same time or maybe the same type of unit that formed. And there's two ways of looking at it. One is called lithostratigraphic correlation, where you're comparing only the rock units regardless of their ages. And the other one is biostratigraphic, where we're using fossils of the same type to link the units. So in this case, we're going to be using both that lithostratigraphic correlation, comparing the rock units between Arizona and Utah, as well as these symbols here represent fossils. So that'd be our biostratigraphic correlation. So if we just looked at Arizona, obviously the oldest rock here would be this metamorphic rock here. So I'll put the metamorphic schist here for the oldest. And then the next event here is this erosion event here, right? So remember, this is the crystalline basement rock. Then we have sediments on top. Well, this must be a non-conformity, right? So the non-conformity would be that erosion event there. So I'll put non-C for the non-conformity. Then we would have the sandstone with the diamonds on it. So we can show that in here. And then the shale with the crosses here. And then the youngest unit here is this limestone, LS, with the triangles, right? So that's our sequence of events in Arizona. What I want you to do is the same thing over here. See that for Utah, the shale would be the oldest, and then we have a limestone with triangles, and then we have a sandstone with no fossils, and then we're going to have this shale or hexagon, and then we have the basalt, which is the youngest thing over here, the last thing to cut across here. So we've identified these units, and we draw the fossils that helped us match those units. You can draw those down here. But then we want to draw arrows between Utah and Arizona here, and those are the correlation lines, right? For example, we know here that the base of this limestone with the triangles and the top of the shale with the crosses must be the same unit over here in Utah. So we draw a line to match those two up, which means the base of this shale is somewhere down, but we don't know exactly where it is, but it's somewhere below or buried in Utah. These rocks, like this sandstone with the diamonds and the metamorphic schist, they're in Utah as well, but they're more deeply buried. We just don't see them. Which means that if we can kind of extrapolate where this contact between the sandstone and this limestone occurs, that would occur up here at the top of the limestone. So here we're matching these units. So in other words, the shale with the crosses and the limestone with the triangles, they are correlated, or they're the same units over here in Utah. So when we draw our stratigraphic column, the order of events, obviously the oldest unit is going to be the metamorphic rock, the youngest is the basalt, but as we're going in over here, make sure you don't repeat these two units. They only show them once because they're shown in both regions. So anyhow, that's kind of something to work on, and I'll let you finish that one up. Finally, this last one, and our lab will also deal with this idea about index fossils. Remember, index fossils have to have a short duration in time. They have a wide area, so if they're marine, living in the ocean, especially plankton, they're all over the place, they're good index fossils. And you have to be able to identify them pretty easily. Now, here we have graptolites, which are plankton, which are kind of these hemichordate plankton. They're kind of important index fossils in the Paleozoic. We have corals. We can easily identify these, but they only live in shallow waters, but they can be pretty good index fossils for geologic time. Ammonites are good because they're swimming cephalopods. They're like squids with shells, and then they're all over the ocean. So they're actually really good index fossils. Crags are living on the seafloor in the benthic environment, so they're really not as widespread as really the ammonites and the graptolites. So probably these two, the graptolites and ammonites, are the best index fossils. So that's based on only the area. Now for the next one, remember we're also looking at, for this short time duration, note that Linguilla, which is a brachiopod, has a very long lifespan, really from Cambrian to present. Whereas Macrospirifer only had a very short duration. So obviously fossils with Macrospirifer are really good index fossils because you have rocks of Middle to Late Devonian age, right? So you can explain your answer there. Now this next section here, we're looking these fossils. And so again, they just represent different types of fossils, but note that they're occurring in different areas A through D. And when you're looking at these fossils, you're going to try to, what I recommend is try to bracket where these come in. For example, these kind of moons on their side here have an area there for a region there for area A. You see that they occur up here in region B, they occur over here in region C, and then they occur over here in region D. So these are widespread, so they'd be pretty good index fossils because they occur in all four areas. When we look at these pentagons, well, they're occurring here and here, so they have a really wide time range, right? So they're probably not very good index fossils, right? So they have a really wide time range, and they don't even occur in area D. So probably these pentagons are not going to be good index fossils. Now, if we look at these circles, they have a narrow time range, so that's pretty good. But note that they only occur in two areas. So again, they're not really good index fossils. And then when we look at the diamonds here, they're occurring in all four areas, but note that they have a really wide time range. So your job is to now, based on what we've seen, answer these questions, right? So anyways, work on this and you'll be submitting this assignment to the Dropbox for lab this week. And I'll see you in the next video.